The material which will be discussed in this video will help you with Lab 5. In Lab 5, you are asked to build a 3 by 3 multiplier or a 3 by 3 unsigned multiplier using half adders and full adders and AND gates. So let us see how the multiplier works. Now you have two inputs A and B. They are 3-bit inputs each, so 3 bits, 3 bits, and your output is P, which is 6 bits. So a 3 by 3 multiplier, let's say A is A2, A1, A0 times B2, B1, and B0. So you can start multiplying. So first you multiply A0, B0, A1, B0, and A2, B0. So these are known as, so this is the first partial product. And the partial product has 3 terms. A0, B0 is the first term, A1, B0 is the second term, and A2, B0 is the third term. Next, you leave the space blank, and then you write A0, B1, A1, B1, and A2, B1. That's the second partial product. And it has 3 terms again in the partial product. Now let's go for the third partial product. You have A0, B2, A1, B2, and A2, B2. Right? This is just like your regular multiplication, right? So that's partial product 3. And again, it has 3 terms. Okay, now how do you realize this? If you look at this more closely, A0, B0 is nothing but an AND operation between bit A0 and bit B0. So you have a total of 9 AND gates. Assuming that you have created all the AND gates and realized all the terms in the partial products. Okay, now how do you compute the sum? So A0, B0 is nothing but P0. That's the least significant bit of the product. That's pretty straightforward. It's just the output of the first AND gate. Now we have A1, B0 and A0, B1 in the next column. Now what component should I use to add 2 bits? The answer is a half adder. So I can use a half adder with these as the inputs. The sum output will be P1 and it's going to produce a carry C1. And the carry is to the next column. Now let's see what happens next. Next, you have 4 inputs or 4 bits. I can use a full adder to add these 3 bits. The full adder is going to produce a sum, let's call it T1, and it produces a carry, let's call it C2. Now I can then use a half adder to add T1 and A0, B2. It's going to produce P2 with a carry C3. Again, in the next step, I can use a full adder to add these 3 bits, assuming it produces a sum output T2 and carry output C4. Next, I can use a half adder, which is going to produce sum P3 and carry C5. Next, I can use a full adder to produce the sum P4 and carry P5, which is the 6th bit. So that's your multiplication result. It's P5, P4, P3, P2, P1, P0. Now, can you draw this whole thing on paper using this information?